Hello, this is Jack Jackson. We're going to talk a little bit about exploring different compositions of two isometries. Um, in order to show that the group of isometries is in fact closed under products, that is, compositions of functions, we need to check that any product of two isometries is also an isometry. Now, we actually proved this earlier. It's actually a relatively simple proof. However, it is instructive to consider the different types of transformations that result from each type of product. Since there are four different types of non-identity isometries, there are 16 different combinations of products of two identity isometries, like reflection followed by reflection, translation followed by rotation, rotation followed by translation, and so forth. There's 16 of those different combinations. Within each of these 16 combinations, there are often several cases with different results, depending on the relationships among the defining figures, positions of the mirror lines, and so forth. In this section, we will carefully consider all the possibilities of composition of the two isometries, and we'll determine the single type of isometry that results in each case. And we're going to be using GeoGebra to help us out, and I've made a pretty comprehensive uh, GeoGebra activity that covers all of these cases and subcases. And here's the link to it. So let's dive in and take a look at that. And this one we're going to focus on the ones where we have a reflection first. So this is the activity that you can see here. You can do reflection first, translation, rotation, or glide reflection first. And then this is choose this for the second one. And we can show the different parts of what's going on by clicking the different boxes. And when there are different options, those will show up here as well. So let's start by, we start with a um, pre-image here, which we can control. It's a triangle, general triangle. And our intermediate image or first image is going to be labeled with double primes. And that will be the reflection over this line. So we start with the reflection. Okay, now actually we've talked about reflections first and reflections second already, but let's go ahead and review that. So there are different options depending on the second mirror line compared to the first one. First one thing is if you go to the same mirror line and you go to the final image, you're going to be right back where you started. So not a lot to show there, but that gets the identity transformation. If the second one is a parallel line, say like here, for example, then when you look at the final image, it's going to be reflected, the intermediate image is going to be reflected over that line. So the question is, what is the relationship between the original uh, pre-image and the final image here? Well, we've seen this before, but hopefully you can see it now that that's just going to be a translation. In particular, that is a translation that the vector for the translation is perpendicular to both of the original mirror lines, and the length of that, and it goes in the direction from the first mirror line to the second one, and the length of it is twice the distance between the two lines. So here you can kind of um, see the distance between the lines here. Okay, is 219.26, and that's going to be, well, that's the actual distance between the pre-image and final image, but the distance between here and here is half of that. So this length of this vector is twice as much. So we get that. Then the last one is for two reflections is if the two lines then intersect. So here we have two lines that have to intersect, and then we do the final image there. And the question then is, how does that original one relate to that one? Is it a translation, rotation? What is it? If you look, I think you can probably see that it's actually a rotation. And We can see it rotating here. I have it rotating around uh, this way. Okay, but it could have just as easily been rotated in the positive direction, the way the vectors are, the way these the arcs are showing up. But if you think of this rotating, well, I've got the angle here in the smaller way, 0.82. If you rotated from here to here in the positive direction, it would end up being twice that. Right? So this is the rotation here is twice the angle between the uh, original lines, and the center of that rotation is the intersection of the two lines. So that covers all of the reflection and followed by reflection. Okay, what if we reflect first and then do a translation? So once again, we have our pre-image here, our reflected mirror line here for this one, and then we can do a translation second, and the translation is controlled by just moving this point here. That changes this vector here. And of course the rest of the figure kind of falls along with it. The translation can be, in any direction. Let's go out here. Okay, so again, let's say, what is the relationship between this one and this one? Well, it's maybe not completely clear um, what this could be. It's interesting to see these line segments that connect these up. When you connect up pre-image to image, that's one of the ways where you can tell what the final image is going to be. Okay. Uh, if it were translation, those would all be parallel and the same length. So it's definitely not that. If it were a reflection, these would all be parallel, but not necessarily the same length. And the midpoints would all line up in a line, and that line would be the uh, mirror line. In this case, they do line up in a line, but they're not parallel. So this turns out that's the mirror line for a um, glide reflection. So which glide reflection is it, and how do these things compare? Well, if we investigate this a little more closely, we can discover a few things here. So if we just uh, we know the mirror line is where these midpoints of these line segments uh, connecting pre-image to image, where those midpoints are on. That is a line. That's the mirror line. To find the intermediate image, just take the final image and reflect it over that mirror line, the one's in orange here, and you get this figure up here that I have in pink. I'm going to label that with the triple primes. By the way, the final image I'm always labeling with just single primes here. And then the vector goes from A to A prime, and notice that is parallel to the mirror line here. So that's your glide reflection. So if you do the glide here and then reflect, you'll get the red final image. Now, how does that relate to the two mirror lines that are to start with? Well, first of all, this mirror line is parallel to the original mirror line, which you can see as I'm moving this around. And we have some other interesting things here. If you take this vector, which was our defining vector for the second translation, second for the translation, which was the second applied isometry, and we resolve it in components uh, relative to, well, either one of these two lines because they're parallel. You get a parallel component here and a perpendicular component here. Well, if you look at that parallel component, that's the same as the vector over here. So it's going in this direction. That is the vector. And if you look at this distance here, you can see the numbers on this particular example. See if you look, that's about 80. That's about 160. This turns out to be exactly twice the length of the one here. So the perpendicular component of this vector, you take half of that distance and go in the same direction. You translate the original mirror line in that direction, perpendicular, by half of that distance, and that gives you the mirror line here. It's the second way to get out the mirror line. So that was kind of interesting. Okay, so let's go now to a rotation second. So once again, we have our original translation, our original transformation. Isometry is a reflection. Okay, so there's our intermediate image. Now we take that intermediate image and we want to rotate it. If we rotate it, we need an angle, which is controlled by this slider or input box here. And we need a center, which I can just move around, anywhere I want. So now the question is, once again, how do I go from this original one directly to here? Maybe not obvious. Could it be? Looks like to me it might be a rotation. So let's see if we can figure that out. One way to figure it out, again, is to look at the line segments that are connected here. Okay. If these stay parallel, let's see, they would need to be parallel for it to be either a reflection or a translation. Okay. In this case, these are in a line, but they're not, but the original lines are not parallel. That's an indication that you have a glide reflection. Okay. Now it is possible for this to degenerate to just a reflection. That happens when the angle is 0. That means you didn't really, what does that mean? What means you didn't really rotate, right? Okay. So how can we see this? Well, again, we can see it by connecting these pre-image to images up. But how do these things compare? Okay, so let's see what happens. If the, where's the original? If the center is actually on the original mirror line, then it degenerates to just a reflection. See that? These lines are parallel as well as their centers lining up. But if it's off of that, then we actually get a glide reflection. Now notice this shouldn't have been too much of a surprise to us. We've looked at this earlier. A reflection followed by a reflection, that's two reflections. We know that's going to be ultimately either a rotation or the identity or a translation. A translation is two reflections, a reflection first and then a translation. That's essentially three reflections. That's going to be an odd number of reflections makes either a reflection or a glide reflection. And same thing for rotation. We have two reflections to make the rotation, one for the original reflection, that's three reflection, that's an odd number, that's going to either be a reflection or a glide reflection at the end. So not too much surprise that this should turn out this way. Okay. If we again, when the center goes through is on the mirror line, we get a single uh, reflection. Notice that the reflection here, the angle between the two mirror lines is half of the angle here, as it turns out. Okay. And if it's not on the center, then let's see here. Okay, let's measure something here. Let's find point of intersection of here and here. Let's measure the angle. Okay, and notice that is exactly half of that angle. So that's kind of what we were talking about there. Okay, and so if this is on the line, we just get a reflection. If not, then we rotate this line by that amount, and that gives you the direction of that the mirror line. Okay, and so we get a glide reflection there. Okay, one more to look at. Suppose we have a reflection followed by a glide reflection. There's sort of two options, or actually three. The mirror line for the glide reflection could be the same, parallel, or intersecting the mirror line. So let's go ahead and do the parallel version first. What happens here? Now we should expect something. Let's see, we got one reflection first. A glide reflection is 3 reflections. That's a total of 4 reflections if we decompose that. So we're going to end up with an even something, even isometry. So it's going to be either the identity, a reflection, no, not a reflection, identity, translation, or rotation. So which one does it look like? Going from here to here. And hopefully you can see that that looks like a translation. You can see that if you connect these up, yeah, that's the translation that's going on. So how does this relate? Okay, first of all, let's just go back before we do that. Let's just kind of go back and see what's happening. So there's the intermediate image. To get the glide reflection, you need a line, and this one is going to be parallel to the original mirror line in this case. It doesn't have to be, but this case it is. And then you have a vector here that's parallel to that for the glide part, the translation part. So the output of the first reflection is here. And then there's a two-step to get the glide reflection. You slide along this vector, and then you flip it over or mirror image it over this line, and you get the final image there. So again, that's going to be a translation. Okay. What is the vector here? Okay. Well, if we do the vector, let's see if I can show it here. If we make this perpendicular to the original, okay, and then make this one, say, parallel to the original, well, perpendicular as well, excuse me, perpendicular from here to here. Let me see if I can find the right intersection. We want this one and this one. Okay, now I can hide this. So now if we look at this, we're breaking this into components, one going from down to this way and then one going this way. Okay, so how do these relate? Well, if you look, this one here is the same as this vector down here. I didn't put the arrow on the end, but notice that vector and that vector are the same. Right? All right, let's do one more thing. Let's look at the size of this guy. Okay. And now let's look at how far apart these two lines are. So to do that, I need a perpendicular from here to here. And I need this point of intersection right there. And then I need the distance between here and here. Well, what happens if you, whoops, I don't have it in the right place. Let's try that again. Let's just use the intersection tool. This one and this one. Now we want to find the distance there. Okay. So that's right at 55. If you double that, that's 110. That's right at 110 there. So if you look, this one is going to be twice the length of that distance. So you take the distance between the two lines, double that, that's going to be the component here, and this vector is the other component, and that gives you this vector here. So that's some interesting relationships there among those different pieces. Okay. If the mirror line actually happens to be on the original mirror line, then you still get a translation, but the vector is the vector from the glide reflection. So it's a translation in either case. It's pretty cool. Okay, what if the mirror lines are intersecting? Okay, so this one is the it's a little easier to see if I move this around. There's a lot of stuff going on here. Okay, so there's our reflection. Let me get rid of this. Okay. That as well. Okay, so now we have a reflection. Now we have the final image here. So now we have a glide reflection here. It's going to intersect here somewhere and have a vector parallel to that. Okay. So this one actually you change this vector, and then this line has to stay parallel. But as long as I don't make this vector parallel to that one, I will get an intersecting thing here. All right. So let's go through the steps again. Here's the original. Reflect over this first line. Get this pre-image down here. Translate it, and then reflect it over by this vector, this image, reflect it over this line. There's your final image. How do you get from here to here? Looks like it might be, we know it's got to be the identity, a translation, or rotation. I think we got a rotation going here. So let's confirm that. We can connect pre-image to image points here. Look at these midpoints here. And they're not in a straight line. But if we take their perpendicular bisectors, they do meet in a common point out here somewhere. It's all screen, so it's hard to see. So let me look at this example here. So they're going to meet at some point here. Well, that gives you the center for a rotation. How big is that rotation? Well, if I go, I've got these arcs kind of going the wrong way here, but if I look at this angle here, the smallest angle here, and double it, I get the angle of rotation here if we're going in the positive direction, not the way these arcs are done, but the other way, coming this way. And that's the same as that here. So if you take twice that plus that, you're going to get 2 pi. So we get a rotation in that example. Okay, so let's kind of summarize what we have so far. Okay, this table gives us the different things when we have a reflection first, and this tells us what the second isometry is, what the result is, and some details. So if it's a reflection and you reflect about the same line for the second isometry, you get the identity transformation. So it tells us a reflection is its own inverse. If we do a reflection and then we reflect about a parallel line, we get a translation. That's by a vector whose length is twice the distance between the mirror lines and in the direction from the first mirror line to the second mirror line, and it's perpendicular to both mirror lines. Do a reflection first and then reflect about an intersecting line, you get a rotation. The center of the rotation is the intersection of the two mirror lines, and the angle is twice the smallest rotation from the first mirror line to the second mirror line. To me, those are probably the most important ones to notice. If you do a reflection followed by a translation where the vector is perpendicular to the original mirror line from the reflection, you get a reflection. The mirror line contains the midpoints of line segments from pre-images to images, and it's parallel to the original mirror line. If you do a reflection followed by translation and the vector is not perpendicular to the mirror, you get a glide reflection. The mirror line contains the midpoints of line segments from pre-images to the final images, and it is parallel to the original mirror line. The vector is the projection of the translation vector onto the mirror lines. If you do a reflection and then a rotation next, where the mirror goes through the center of the rotation, you end up with a reflection. The mirror line is a rotation of the original mirror line about the center of the original rotation, and the amount of rotation, the angle is half the amount of the original rotation. The mirror line contains all midpoints of line segments from pre-images to their image points. A reflection followed by a rotation, the mirror not going through the center of the rotation, is a glide reflection. This mirror contains all the midpoints of the line segments from pre-image to their image points. If you do a reflection followed by glide reflection with the same mirror line, you get a translation, and the vector is the vector from the glide reflection. If the reflection is first and then is a glide reflection but has a parallel mirror line from the mirror line for the reflection, you end up with a translation. The vector is the sum of the vector from a glide reflection and the vector in the direction from the reflection mirror line to the glide reflection mirror line perpendicular to both and twice the distance between the two mirror lines. And a reflection followed by glide reflection about intersecting mirror lines is a rotation. So the center is the intersection of the mirror lines, and the angle is twice the smallest angle from the first mirror line to the second mirror line. So that gives us a summary of what we found for composition of two isometries where the first one is a reflection. So in the next videos we'll do one where the first one is a translation, where the first one's a rotation, where the first one's a glide reflection. And so we'll do this to exhaust all the possibilities. This is one of the longest ones, is with the reflection first, because there are so many different subcases.